Today, Academic Daddy will be teaching you component vectors, how to go about it. Now, see, I've already drawn the diagram. There's a find the resultant of the 5 coplanar forces, 19 Newton, okay, 19, 15, 16, 11, 12, all Newton, acting on an object at A as shown below. So, at A as shown below. So, what you need to understand whenever you see this kind of question is that there's something like this, and we call this quadrants. And what this quadrant is talking about is that at fourth quadrant, this is fourth, this is first, this is second, this is third. So we call it cast. At fourth quadrant, only cos theta is positive. First, only all the trigonometric quantities, ratios are positive. Second quadrant, only sine is positive. Third quadrant, only tan is positive. Now you need to know that if this is the first quadrant, every value is positive because y is positive, x is positive on the right hand side. Now on the left second quadrant, we have y positive, x negative. So if you are resolving this vector towards this side, it will be positive. If you are resolving it towards this side, it will be negative. Then if you're resolving this vector on the third quadrant, everything to x will be negative and to y will be negative because y down here is negative, x this way is negative. Then this way y is still positive. So if you're resolving this vector, like pulling it down here, it will be negative on y. If you're resolving it to x, it will be positive. So if you know this, let's fall back to the question. So whenever you see this question, they tell you to resolve. They give you a resultant and you are faced with this kind of question. You do the opposite of what resultant is. Resultant is bringing two separate forces together and it becomes one. Resolution is simply taking one force and putting it into x and y axis. So that I have, resolving this now, I'll have the force. They gave me 19 Newton, they gave me 15 Newton, they gave me 16 Newton, 11 Newton, and 12 Newton. Now this is x-axis or x components. This is y-axis or y components. Now if I know this, to resolve this now, we've drawn it. So notice that this is the 19, the force of 19 is at x. And notice that at x is 19. And when you are this way at x, you are already on the horizontal plane. You've already been resolved to horizontal plane because every force that is not on the horizontal and y, the essence of resolution is to get it to belong somewhere. Take it to either y and take it to or to x. And since you can't give to this one and not give to this one, you take it to either ways and get the result. But when you see a particular force already at y or already at x, there's no need resolving it. So since this is at x-axis, at x-axis we have 19. So we have this force to be 19 at x-axis. Now at y-axis, you can't take it to y-axis because it's at x. So the effect it has on y is on this place, this way. So at x-axis, notice that y is 0 here. So y is 0. Now 15 Newton, the 15 Newton I'm seeing here. When I try to say bend this force to come down here, bending it to come, anything that happens around x-axis is what I choose to call absu, or whichever one you want to use, but I like to use absu strict today. Chai. This is away from the angle, use sine theta. Towards the angle, use cos theta. So absu strict today, chai. Or you can use ansu strict today or However you want to put it, but this is the one I use, ASTC. So if you know this, that means if you look at this angle now, 15 Newton. If I'm trying to put 15 Newton this way, you see that the angle is already on X, it's towards X. So this will be using cos 15 cos theta. And the angle there is 60. So it will be 60 cos 60. Now, to resolve this, now let's say I'm taking this first to y now. To resolve it to y, taking it to y, it will be 15 sine theta, which is 15 sine 60. Now let's come to this side. If I'm notice this thing now, notice this, because I could say, I could have killed a lot of people. I could have said, let's say this is 60. Angle on a straight line is 180. I can say, come and do 60, 60, or you say 180 minus 45. 180 minus 45 is 135. And whatever you do here with 135 is the same thing this one will give you, as far as you remember to obey this rule. To say, since this 45 is down here, it means that it's negative. So if I'm resolving it towards x is negative, and if I'm resolving it towards y is positive. So if you cannot do that angles on a straight line minus the angle you are given, remember to use this, so that if you use this, you use the angle you are given anyhow. You use the angle you're given, so far as you remember to put this. But if you cannot remember to put this, then you will always remember to go to the angles on a straight line and subtract that angle given from angles on a straight line. So since I want to teach you using this, I will now say this is on 45 degrees. It's the angle is towards x, so I will say towards x is cos I'm using. It will be okay on x. It will be, instead of 45, it will be minus 45, because it's negative. Minus 45 degrees, that is cos minus 45 degrees. So first of all, let me, on the x-axis, notice that the minus will affect everything. So minus 16, sorry, it will now be minus 16 cos 45. This 45 is coming, this 45 is here because the minus is already here. The minus will affect all the answer. So on the y-axis, away from the angle is not on the angle. Notice that this angle is here, away from this angle. Taking this way now, you will remember that y is positive in this quadrant. So it will be 16 sine 45 degrees. So if you check it, you see that sine 45 and sine 135, sine 45 and sine 135 gives you the same answer. So that means that you need to be obeying this. You need to be obeying this rule. If you are not obeying this rule, if you don't remember this rule, you need to remember to always do angles on a straight line minus given angle, so far as the angle is not on this right hand side. Any angle given to you here, 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 like any angle given to you here on the left hand side, both up and down, you will always minus it from 1/8, unless you remember to use this approach, this quadrant approach. So the next one is 11 Newton. Notice 11 Newton. We are using the quadrant approach. 11 Newton. This means that everything that happens around here will be negative. Everything happening around here will be negative. So for that reason, let me put my minus, because on the third quadrant, x and y are negative. So let me put my minus sign on both the y and x axis. So if I know this, I will now say 11 cos 30 degrees. I told you, once you are using this quadrant method, any angle given to you, make use of it like that. Now 11 away from the angle, 11 sine 30 degrees. So now for 12 Newton, notice this is 12 Newton. Shebi? Notice this is the 12 Newton given to us. So for 12 Newton, notice that 12 Newton, this 12 is at y, and I told you since it's already as y at y, there's no need resolving it, because every other one given to us is because it's not at y or x, so we are trying to pull it to y and to x. So this is already at y, so it is negative at y. See it, y value here is negative, so it's going to be on the y-axis, it's going to be minus 12, just like that. I don't need to put sign or anything to it. Now on the x is 0, because this thing now here has effect on x at this midpoint origin, so this is 0. You can see 0.0, 0.0. So since I know this, let me now get the results. Okay, sorry, let's do it this way. So the results, so this is force x-axis, y-axis. So when I do the punching, I'll have that the force of 19 Newton is going to give me here 19 0, and this one for 15 Newton, 15 cos 60 will give me 7.5, and 15 sin 60 will give me 13.0. Now 16 Newton minus 16 cos 45 will give me minus 11.3, and this will give me y-axis will give me 16 sin 45 will give me 11.3. Now 11 Newton will give me minus 11 cos 30 will give me minus 9.5, and minus 11 sin 30 will give me minus 11, will give me minus 5.5. Then the last one is 12 Newton, which is 0 down here and minus 12. So once you get this, you need to get the summation, or you say the resultant of these forces, everything. Now when you've done this on the x-axis, you need to get all the x. Notice that this is like when they give you so many x, so many things that can give you x and y, so you need to resolve everything. Now after you've resolved, you need to now sum it up to get the single force, so that I now have that on the x, forces on x is equals to 5.7 Newton, and forces on the y is equals to 6.8 Newton. So if I finish doing this, notice that for the fact that I'm through with this, what I have is x and y, and all the angles given to me are on 180 degrees. So for the fact I'm done, I can now use whenever you are through with this and no angle is specified, you have just x and y, you just use your Pythagoras theorem, which is the same thing as saying r square equals to x square plus y square. So this is going to give me r square is equals to 5.7 square plus 6.8 square. So this is going to give me 32.5 plus 46.2, which gives me 78.7. So r square is equal to 78.7. So take the square root of both sides, so that r becomes square root of 78.7, which is equals to 8.9 Newton. So this is the resultant. So when it's force, we are talking about resultant, which means they said displacement or distance, it will be in meter. So now to find the angle theta, it will now be tan theta is equals to always y over x, that is sine over cos, so that this becomes 6.8 all over 5.7, so that this now becomes equals to 1.2. This is 1.2. So theta is equals to tan crossing over becomes tan dividing, is multiplying here. Tan inverse is the same thing as 1 over tan, so tan over this thing, so this is tan inverse 1.2. This is the same thing as saying 50 degrees. So the angle between them, the angle between the two forces is 50 degrees. Know the difference between when they say angle between the two forces and the angle between the resultant and the two forces. Two different things. So thank you. Like, share, subscribe. Academic Daddy.